My name is Miles Ward. I'm a solutions architect from Amazon Web Services. So I've helped some of our tiniest little startup developers all the way up to some of our largest infrastructure deployments with massive enterprises ensure that they are all of the normal things you've heard about cloud, highly scalable, elastic, low price, but also very, very secure. So I'm going to talk through today a couple of different specific things related to what we think of as the slow change that everybody is going through around IT infrastructure, from asking the questions about can AWS meet our requirements to maybe more of a question around the general question of how do we ensure the security of our applications. This is what I would describe as a security and compliance overview. I don't think you can take any approach to infrastructure deployment without reviewing the basic building blocks. What are the components that we've deployed? What I'm hoping to cover is a set of sort of key security concepts, what Amazon has done for our part of the job of making sure that our infrastructure and applications deployed on top of us are secure, what the features and assets from Amazon that are available for you to use to deploy secure systems, and then some guidance about application design on top of these resources so that you can deliver secure infrastructure to your customers, to their customers, and beyond. Hopefully at this point everyone is loosely familiar with the concept of infrastructure as a service and Amazon Web Services as the world's leading cloud provider. We believe that this set of infrastructure components, simple things like EC2 servers that you rent by the hour, storage that you rent by the kilobyte, all the way up through more advanced services like Elastic MapReduce for high performance Hadoop processing, and Elastic Beanstalk, a simple platform for Java. All of these tools represent a computing platform, and that platform is extended by our partner RightScale. We think that there is a natural synergy between these two systems. We've been a long-term partner with RightScale and believe that these two systems work together in a way that extends both platforms. This platform depends on a concept that I think we'll talk at length about, and I appreciate everybody sort of making room for folks as we fill in the room. This concept is called the shared security model. We've been told by a lot of folks that this has got to be unique, that this is somehow magical or different because of cloud. But in reality, this is typically a very normal division in standard co-location facilities, in standard on-premise infrastructure facilities. You have one group of people, typically your IT operations staff, that do work around operating systems and application deployments. They manage firewalls. They have sort of software level control. There's probably a different group of people that are spectacular at pouring concrete and building buildings and ensuring that your buildings don't fall over at random times during the day. Amazon has built our model where we've slid the measure a little over, where now we take care of the physical infrastructure, the concrete, the racks on the concrete, the machines in the racks, the operating system on the machines, and the hypervisor that operating system supports. Above that remains your task. So in any kind of security design, it's important that you look not only at our part of the job, which is making sure that the physical infrastructure, the logical infrastructure that manages that physical infrastructure, the buildings, the people that have access, all that stuff is secured. It's also important that you pay attention to what controls and tools you have to secure your applications, your deployments. We think we've done a great job, but who says? That's kind of a bold statement. I think Amazon has done a great job making sure that our infrastructure is secure. Toward that end, we've gone through a pretty rigorous certification process. That involves a whole bunch of outside third-party auditors coming through and making sure that we've done what we say we do. We actually publish all of our security controls. That's a white paper that's available online. And those controls meet up with a series of certifications and audits. So the recently new formatted SSAE 16, which is kind of the same as the old SAS 70 Type 2 audit, ISO 27001, PCI DSS Level 1, FedRAMP, FISMA Moderate. Those are a series of evaluations that go through physical infrastructure step by step, little part by little part, and we'll talk about some of those parts downstream. All of those evaluations are the same kinds of standards that are applied in co-location facilities and at major IT infrastructure on-premise facilities. We think we should be held at least to that same bar, and we've been successful in passing these certifications in places where some other competitive partners have not. Exactly the same as the first list, where there's what we're in charge of and what you as customers are in charge of. Our customers, together with us, because we think it's a partnership, have deployed SOX compliant, HIPAA compliant, FISMA compliant, DICAP MAC 2 or MAC 3 compliant applications on EC2. So what are all those big squishy words mean? SAS 70 Type 2 is an audit. So what that audit follows is a thing called the COBIT controls. The COBIT controls are just a list of all the different ways someone should have a lock or a process or a system to ensure that that part of the infrastructure is secure. So that goes with, how are the people in our security organization secured? What is the life cycle of employees? What are the logical controls that are in place? How is data handled securely? Each of those is a whole list of checkboxes that someone's got to go through and ensure that we do things the right way. The difference with SAS 70 Type 2 and other places is at Amazon and any of the security providers that follow this standard, we actually get to pick which test is used to evaluate us, which is kind of a cheat, right? We say, ooh, we want you to make sure that you do this, and then they come and check and make sure that we do that. We picked the hardest one. It's called COBIT, and it includes all 9 of the control objectives. There are many other folks that have a SAS 70 Type 2 audit, which is they've taken a test, but they've picked a much smaller number of controls to evaluate against. So you can see it's pretty clear. We've gone through and done that not only for all 9 of the objectives, but we've done it in all 7 of our regions, and to ensure that we're very comprehensive in that process. ISO 27001 is not an audit, it's a certification, and that means it's different. What's different about it is, rather than us giving them the test that we want given to us, they give us the controls and tell us we have to meet them, and then go through and evaluate against that. So we've gone through and done that process. It follows with the enumeration of those lists. That's called ISO 27002. That covers EC2, S3, our virtual private environment, and the systems that support those, like EBS and all of the internal S3 access controls. It does include all regions and is not done by us. It's EY's Certify Point that comes out and evaluates to ensure that we've met that cert. Similarly, PCI DSS Level 1 is Visa coming out and saying, you've done all of the things from a physical infrastructure standpoint to secure holding customer credit card data. We've done this in a pretty special way because we are a part of Amazon.com, and Amazon.com has its own QSA and its own set of QIRA folks that come in and work security controls. So they've gone through and done our audit to ensure that AWS meets the most stringent controls. They're a part of the Visa Alliance. They can process credit cards, so they've been able to go through and ensure that we're doing things in the right way. That's also an all-region certification. We have thousands of customers at this point that are using Amazon Financial Payments Service to run payment processing through Amazon. This is on top of that, more sophisticated than that, in that you could build your own payment processor on top of Amazon and sell it out to other customers and meet the Visa specifications. So how do we do all that? It's a lot of people coming and looking at our stuff. The basics of those rules, there is physical security of our data centers. We have been building buildings like this for a long time. There are very clear physical requirements when you build buildings that meet the structured controls that we've evaluated. One, they're nondescript. There isn't any marking of them on normal maps. They won't come up on Google Maps as an identified address. There are separated physical distances. They have to be a certain degree far away from local roads. There are physical berms that protect arbitrary drive up. You require multiple levels of two-factor authentication to ensure that no one is getting in and touching the machines. There's also this very important control that is a separation of physical and logical access. So any of the guys who have the stuff to factor authenticate in, to walk into one of the data centers, don't have access to any of the computers computer stuff that it takes to change something in one of those data centers. So they're walking into a room full of computers with numbers on them, and the best they could do would take some of them and run out. Our systems, any of the data control tools that we've built are all encrypted and are all prevented from that kind of manual tampering. So we'll go through what that looks like at much greater detail. We also follow, inside of that physical infrastructure, a very, very careful process of configuration management. There's no system by which to take actions logically in AWS that are not logged, that are not documented, that are not typically multi-user authenticated. So you have to do something with another team member in order to ensure that you're taking best steps. We also have a whole process of communicating with customers around these changes. There are ancient machines that need to be updated. We'll notify you if there's some kind of an issue where you need to understand what's going to happen. By and large, configuration changes we're able to complete those kinds of things without any impact to customers. EC2 as a system, one of the 28 products from Amazon, has its own set of controls. Because EC2 is a supporting service underneath several of the other services, we have a whole more detailed statement about exactly how that is controlled. So the host operating system, to sort of describe, I'm going to go back to this slide in a second, but it looks sort of like this. You have the physical interfaces, the box this machine sits on, a set of virtual controls, the security groups, and the firewall that aggregates those security groups at the physical interface level, and then the hypervisor, which exposes one operating system, one image, one AMI for each individual customer. If this is one box, you can potentially, because it's a multi-tenant public cloud, have multiple different customers, but because the only way you're accessing each customer's data is through this virtualized security group, there's no way to cross-instance communicate, there's no way to share data back and forth, there's no way to even do multicast or broadcast or anycast networking. So those kinds of controls allow us to follow these systems. So say, for example, things like ensuring that our admins can't log into your resources. If you get an email from a cloud provider that has a picture of an SSH session into one of your boxes, it is not a good thing. You should stop using them and come over to somebody that can't get into your machines. That is a super, super big violation of security and should raise warning signs for you. We are not allowed to do that. There's no system by which we could do it if we wanted to. That's what the SSH security group control plane provides. Below that, maybe a layer down, all of this stuff sits on top of a network and a set of disks and a set of machines. So we have our own proprietary disk management system that ensures that no instance is accessing a previous instance's zeros and ones, blocks are randomized. Physical disks themselves are actually destroyed. We don't return any disks of any kind. They go through NIST level destruction, DoD level destruction procedures. We're basically throwing hard drives in a big 8-inch chipper shredder. As a result, they are really, really gone, and no one else is recovering that data. Similarly, there's this more advanced set of network controls that are available to you as a customer around which instances talk to what other instances, different than maybe in your local physical network environment where there are computers and then these very separate things called firewalls that are part of an onion routing or a layered routing topology. In EC2 and Amazon, every instance has its own software-based firewall called a security group that lives outside the instance but protects it. That separation of infrastructure and really an extension of firewall-like capabilities to all of the machines that you run provides a set of controls that can be difficult to implement in a physical environment. So that network confidentiality or flow security, sort of builds onto a kind of cryptographic control. So we provide our own controls, which ports are accessible over which IP addresses to which security groups. But you could certainly overlay above us a whole layer of further control from a network privacy standpoint. So we certainly have customers that build virtual private networks on top of EC2. If you don't want any of the traffic moving around on us to be visible at any time by anyone, you can certainly run a VPN, either IPsec or SSL-based VPN without any kind of issue. Your instances in Amazon sit inside of our network context, and part of the service that Amazon provides to you is a set of network controls at the macro scale. So every availability zone, every machine, every region, they're connected out to the internet, and you can sever that connection using the security group. But that internet connection represents a kind of risk. Certainly you could come subject to a distributed denial of service attack or a man-in-the-middle attack. Each of these different kinds of risks that are present in the public network, Amazon has our own mitigations against. So we've really blocked out all the options for IP spoofing. The host operating system doesn't have any access to or control of outer network devices and can't create that kind of piece. If you take a machine and open its network card in a way that's called promiscuous mode to listen to all traffic on the network, the only traffic that you'll hear is traffic destined to your instance. That's a part of the Amazon control tier. Same kind of a control around man-in-the-middle attacks. Every one of our endpoints is protected by SSL encryption, so it's impossible to stand in between there. You have an encrypted key on either side, and each EC2 instance's host keys are generated at boot time, so there's not an opportunity to run in there and replace which key. You have the other side of the key. That's a rapid overview of the controls that are present at Amazon. There are a whole bunch of pieces that we've built that allow you some configuration control, you some implementation control to ensure that the designs you deploy are just as secure as the stuff we've done on our side to make sure there is a secure build. So part of security, we think, is a design for continuous availability. One of the very consistent ways that people that break into things or violate things or cause problems with things is to take them offline. We think leaving your systems, keeping your systems up and working is an important part of surviving a different classes of attacks. We don't have cold data centers or offline DR facilities or any of that other kind of stuff. We think that high availability is the goal of every one of the applications that you design, and so we've built a whole bunch of systems to support high availability. One of those is this concept, and it's maybe easier with a picture. And I think you've heard RightScale talk about it, where Amazon is not a cloud, AWS is not a cloud, but multiple clouds. So each of these regions are their own independent, logically isolated cloud infrastructure that has its own internal high availability design. So in US West, which is in Northern California, there are multiple data centers. They are between 5 and 15 miles apart, and they are connected by a private Amazon network ring. So there's no public internet traffic required to move data from this building to this building. It's all on our own wires. The result is that you can build a system that distributes load across these two zones, and if this zone fails or is attacked or is bombed or there's an earthquake or Godzilla comes or whatever it is that takes this one out, you can definitely survive because the other building is far enough away and is logically isolated in a way that that it will survive. Similarly, the same API controls are used to deploy on all the different regions. So while this system is logically isolated from that system, it's the same sets of knobs, it's the same sets of codes. So we do have a lot of folks that follow the model of high availability within a given region and disaster recovery across the region. So if Godzilla gets really aggressive and chops US West off of the planet by sinking California, then at least you'd be able to recover in US East or something like that. Or our brand new data center in Oregon, which just got launched last night. Woohoo! So the separation of the physical resources, where there are, that's one sort of security feature. You can build the ability to deploy in multiple data centers very, very easily, very, very straightforward as a part of your security approach. Another thing to subdivide is access. So we've built a set of tools called Identity and Access Management. That's a credential, a least privileges design system that allows you to build individual API keys, access keys for users and groups of users. Those keys allow access to specific individual APIs from Amazon. So for example, you can build a user who can turn machines off but not create new machines, or a user who can create a new queue in our simple queue service but not delete any of them, things like that. So we have a whole automated build tool that shows you sort of best practices, normal configurations. Here's a power user, here's a read-only auditing user, here's a user that only has access to certain tools. We think of those users as being useful not only for your actual developers, your actual IT staff, but that a user should be created for each application. So if you have a software program that wants to back itself up and wants to use S3 for backup, rather than giving it a master key, which if compromised could be used to do all sorts of hilarious things, you'd give it a key that only has the ability to write new data to S3. That least privileges design is a really great way of ensuring that you're only able to do the things you're only supposed to be able to do. An extension of that principle, this creates permanent keys, keys that you can create and then subsequently delete or update. We have another service called STS for temporary credentials. So let's say, for example, you have a new application that you're developing for your phone, and you want it to be able to back pictures up to S3. Rather than handing out a unique permanent key to every phone, potentially millions of keys, you can instead build a service that allows tokenized authentication back to our APIs. It's a very, very powerful tool for reducing the scope of the privileges you extend to your users or your customers. So that can also be used for identity federation. So we have a lot of folks that are building Active Directory single sign-on authentication to AWS built on this tool. So design a workflow model. You build a key, you create a session by working from your identity store, your login operation, your system for identifying the user, which acquires a token from our systems, sends that out to the devices, which then have access to the service APIs in a time-limited way. Those can last anywhere from an hour to 36 hours. So you can build an application that only lets Billy download that one file just once, all the way up to, they have a long-running session that will allow them to do quite a few different things. We also believe that cloud shouldn't be all not or all virtual, that occasionally a physical device can be not such a bad thing. That is certainly in place here in MFA, a token system for authenticating your API commands. Really sort of obvious. If you want to log into our console, you're going to need this key to be able to do it. Maybe not quite so obvious. A really powerful utility for this is a function called secure delete, where you can create objects in our S3 storage system that cannot be deleted if you don't have the key. So for things like source control or escrowed objects or worm data or other things like that, if you need to prove that no one deleted it, create the object and throw out the key. Now it's impossible to delete those objects. So that kind of design, that kind of physical control allows you a whole set of real-world physical processes around data that maybe are hard to implement if you have only logical controls. Another really sort of clear, normal thing that we certainly need to talk about is network infrastructure access control. So this is a normal N-tier, 3-tier application. It's typical design for that using the AWS security group as depicted here in the firewall would be that the web tier has only access to ports 80 and 443, and then data from the web tier can access the application tier by way of the security group. That's an ingress-only stateful firewall filter. But then engineering staff can certainly SSH into each of these machines over port 22 using individual IP address authentication. That's a completely normal topology. There are thousands and thousands and thousands of customers that are deployed this way. But there are some network systems that need more controls than this, need the ability to prevent network egress as well as only network ingress, that need the ability to create private subnets, things like that. So we've built a system called Virtual Private Cloud. Probably have heard of that. We think of another way to think of VPC is virtual networking for EC2. VPC is now available in all regions, in all availability zones. So it's very easy to get started with. It's an environment where rather than the dynamic network addresses that you get in EC2, you get static network addresses which you define in a subnet which you define in a network container that is not penetrable except for by accesses that you define. So much more structured, much more controlled environment. An idea of what that looks like. This is one model. There are two. We'll look at both different ways. One, say for example, I've heard a lot so far at the conference about bursting workloads where you have a data center already, you like that data center, it works awful nice, occasionally you need some more servers, so you'd like to be able to use your network addresses, you'd like to be able to burst into EC2. So you create a VPN, VPC inside of EC2 with a subnet you define, with a set of machines with addresses that you define, and you create a route back to our hardware VPN. That's a pair of IPsec BGP tunnels, and you connect that to your physical network and route traffic back and forth. So now you can burst operational workloads in here, crunch a bunch of numbers that you don't have the machines to crunch here, and then send that data back over your network. This subnet is not world routable. The addresses are not public readable. There is no way to get any data anywhere other than over back to your network. For example, if you want to back this machine up to S3, you have to go through your route, go out the VPN gateway, go to the customer network, go to the internet, come back in through the gateways and over to the EC2 and out to S3. That's maybe not the grooviest way of doing it, so we added a whole bunch of new features to VPN. This is about 4 months ago. We've added a set of systems called a public subnet in addition to the private subnet. So now you can create a NAT instance that allows transversal from a private subnet into a public subnet, which can talk to the internet. This network topology, we think, allows you to do as sophisticated a set of network topologies as you do in your own physical data center on EC2, where you have your own public subnet, multiple of them, elastic IP addresses to give persistent internet routable addresses to those instances, your own routing tables that allow you to define however it is you want to move internet around, and your ability still to route directly to our internet connectivity and out to internet customers. This network overlay, this set of network controls, also allows a whole set of other pricing and deployment models. So we've heard for folks from regulatory reasons need access to dedicated machines. I want this box and I don't want anybody else on there. Fine, marvelous. We will sell that to you. That's a $10 an hour flat fee per region, and it's a small hourly charge up on the instances, but that lets you run as many different machines of as many different kinds in any of the availability zones, all at this sort of one flat fee. So if you need one box dedicated, that's going to be fairly expensive. If you need 1,000 box dedicated, it's not any more expensive than that. So very, very straightforward way to get a very clear isolation that says no one else is on your hardware. A whole other set of systems that we've built. We've mostly been talking about EC2 and VPC networking. There are, in fact, 28 products. So we don't have time today to talk through security ramifications for every single one of them. But S3 is probably the second most important, the one used by the largest individual number of customers. S3 supports not only the identity and access management control tools, where you're providing individual users the access to create or delete or add or remove individual files. It also has its own bucket and object level controls, where you can say you must be on SSL to access this object, or you must have your token available to delete it. You can version objects in S3, which also provides a level of protection, so no one can upload bad bits and destroy your old good bits. Lots of ways to defend individual pieces of data on S3. We've also looked at, in terms of best practices, in terms of designs that work on AWS. There isn't anything that's fake or ghosty or quasi about AWS. Amazon is the real world. So any of the normal practices, if you have a guy who usually follows procedure A on going through and ensuring that an application is secure, let him do exactly the same thing with us. I am willing to bet that your processes are good processes and that they are likely to add significant value when applied on our infrastructure in many, many ways. This stuff is the same as your stuff. If you have 4 machines and this is how you secure the network between them, you should secure the network between them in the same way on Amazon. Amazon. If part of your application validation is ensuring that when somebody logs in, a weird picture doesn't come on, log in and make sure that a weird picture doesn't come on. So follow those normal processes. Certainly we recommend that folks follow the sort of general principle of least privileges design. That means that any individual system should have only the bare minimum of credentials required in order to be able to do the work that it's supposed to do. That can be confusing and difficult to implement. I know for sure that when I can't get something to work, the first thing that I throw out is all the security constraints. Let's open all the ports up. Let's use a default password. Yes, I should be the administrator user. Of course I want to be root right now. All of those kinds of checks. It is worth the time and energy to step back after you've gotten something to work and figure out how to get it to work securely. That's a process that is, we think, an ongoing, constant evaluation that many businesses are at some step in. So we're happy that as you look at deploying new things on Amazon, that you re-evaluate and re-investigate those kinds of designs. Another part of security we think is service-oriented design. If you can build independent, loosely coupled, self-sustaining applications that aren't dependent and aren't failable, built on others, that have their own authentication, that have their own security model, that ensures that each one of the teams potentially that you have, or separate developer groups, that they're all following these other best practices to ensure that a given application is just as defensible as the entire application, or a subcomponent is just as robust as the whole components. We also think that you don't have to do the same processes to everything. So if you put up a public website and it was going to be in your DMZ in a co-location facility, maybe you can treat that with a different set of evaluations, a different set of controls than you do with the credit card data of your customers. Certainly worth going through the process of classifying your resources, identifying which kinds of systems do we need to follow, what kinds of processes, and protect those systems accordingly. That we think is also not a one-stop event. You're probably going to want to go through that on a cyclical basis to evaluate and reevaluate as this application started to capture more and more sensitive data. One we've seen a lot is folks building like internal collaboration systems or internal data sharing systems that all of a sudden find that their employees are putting a lot of very sensitive, very customer-oriented, very secret data in, and now they need to sort of ratchet up the level of security that they provide on those kinds of services. So make sure that you go through and evaluate the applications that you're building to see what level of security is important. Similar to the SOA design statement, security at every layer, where it's not just about securing this sort of outer crunchy shell and allowing a warm, squishy interior to be as an attack surface for individuals. In Amazon and in most cloud environments, every one of the machines is actually effectively at the edge of your network. It's right on the outside, it's proximal to the internet, it's connected in many ways to the internet. So it's important that at every one of the layers, even all the way back in the guts of your database security tier, you certainly are going to want to have security and controls at each of those different layers. We also think that you can't trust any of these systems. You're going to have to inspect and test and test and test and test. One suggestion and request that I would make, it's against Amazon Web Services terms of service to do penetration testing without asking us first. So we certainly want to know about that. We go through all sorts of really aggressive, maybe things you might not like, when it is you do something like that without talking to us. In a lot of ways, Amazon has built so many of these systems to be tolerant of self-service and independent configuration. That's one of the places where it will be a benefit to you to come say hi. This was done at approximately 90 miles an hour. If you would like the 35 mile an hour version, we have much longer full-form documents that provide this information, give you much more detailed information about how to do things like penetration testing, what are the processes there, has a lot of information about not only sort of our security controls and what our sort of risk and compliance approach has been and will continue to be over time, but also has more information about identity and access management and the other features from Amazon that support the security controls that you want to implement. we are constantly building this system. I'm not sure if you guys have watched, but we're at a running average of 3 features, or a feature every 3 days. So we are in fact building more stuff on this in this area. So your input is really, really critically important. Either in the next 2 minutes when I'm going to sort of open the floor for questions, or after, happy to take any of your input. I literally meet with our product teams on a weekly basis to describe the things that our customers want. It's really important that I get an idea of what are the features that are missing, what are the gaps that people have as they try to build systems, and happy to field as many of those questions as you have today. I'm an enterprise solutions architect, so I've done this kind of work at scale, and happy to have that outreach happen not only today but at any time. Please don't feel free to contact me on these channels.